Some knowledge of logarithms is necessary to solve problems in Chemistry 2. In simple terms, the logarithm with base a of x is the power that you would have to raise the number a to in order to get x. In chemistry, we generally deal with two kinds of logarithms. One of them is known as the normal logarithm, which is log base 10, and the other one is the natural logarithm, which is typically shown as ln, and this is going to have a log base e, which e has a value of 2.718281828. So, for example, the log base 10 of 10 would be equal to 1 because 10 to the first power would be equal to 10. Likewise, the log base 10 of 100 would be 2 because 10 to the second power is equal to 100. So this actually allows us to solve for x in this problem. The first thing we'd want to do would be to take the logarithm of both sides. One of the properties of logarithms allows us to bring this x out in front of the log. At this point, we can get a value for the two numbers that have logarithms in front of them. And now it's just a matter of solving for x. And we can see that the value of x here is 2. Another useful property of logarithms is the one that allows us to expand when two numbers are multiplied or divided. So for example, in this problem right here, where we have a natural log of x over y equals 14, can we solve for x if we know that y is equal to 2? To solve this, first thing we're going to do is write the natural log of x over the natural log of y is going to be equal to x, natural log of x minus the natural log of y equals 14. And we're going to plug in the natural log of y to be the natural log of 2, so it's going to be natural log of x minus natural log of 2 equals 14. At this point, we can move the natural log of 2 to the other side, so we're going to get natural log of x equals 14 plus natural log of 2. And the only thing we have left to do is to get a number for the natural log of 2, add it to 14, and take the inverse natural log of x. So the natural log of 2 is 0.693. So then natural log of x is equal to 14 plus 0.693, and that's going to be equal to 14.693. To finish it up, natural log of x is equal to 14.693, and so what we're going to do is take the inverse natural log of both sides, so e to the natural log of x equals e to the 14.693. E to the natural log of x that you see here is just going to be x. So we can bring that x down, and then we'll use our calculator to get a number for this. So the value we get is 2.4 times 10 to the 6th. So these are the two things that are most useful for us in general chemistry. There is one other thing that might be useful depending on which calculator we're using, and that is the ability to solve for a natural logarithm if we don't have a natural log button on our calculator. So the way that we do that is to take the logarithm base 10 of x divided by the logarithm base 10 of e, and remember that e is equal to 2.718281828 and so on. And so what we're going to do is we're going to take the logarithm base 10, which is the normal logarithm on your calculator, of x divided by logarithm base 10 of e, that is this number over here, and we're going to set that equal to the natural log of x. So if you don't have an ln button on your calculator, you can solve it by taking the base 10 logarithm of your number divided by the base 10 logarithm of the number e.